Hi there, Mr. Sutton here, bringing you the BC Calculus 7-4 Extra Practice Number 2 solutions on Taylor series. For this problem, we want the third-order Taylor polynomial generated by radical x at x equals 4. So we have to start by finding f of 4 itself. That's just the square root of 4, which is 2. And we also need 3 derivatives to get the third order. So let's go ahead and get the next derivative. Since this is really x to the 1/2 power, derivative of that is going to be 1/2 x to the negative 1/2. And we're going to be evaluating that at 4. So this is really going to be, let's see here, square root of 4 in the denominator. So we have 1 over 2 radical 4, which is 1 over 2 times 2, which is 1/4. Next, we're going to take the next derivative of this and apply 4. So let's see, this is going to be negative 1/4 x to the negative 3/2. Now if I plug 4 in here, I've got a few things going on here. So we have the square root of 4, which is 2, and then we have to cube that, so that's 8, and that's all in the denominator. So we have a 1/8. Negative 1/4 times 1/8 is going to give us negative 1 over 32. And then finally, for our third derivative, we've got negative 3/2 times negative 1/4 using our power rule here. So that's going to be a positive 3 over 8 x to the negative 5/2. And plugging 4 into that, so square root of 4 is 2. Raising that to the 5th power, now we have 32. So this is 1 over 32. 3 over 8 times 1 over 32. That's going to be, let's see, 3 over 256. Now we have to plug it all into our Taylor formula. So our first term is just going to be f of 4, which is 2. And this is the third degree polynomial now. And next we have f prime of 4 times x minus 4. So f prime we saw was 1/4. So that's going to be 1/4. And we're also going to have an x minus 4 next to that. So x minus 4 over 4, I guess, is another way you could express that. Next, we're going to have f double prime of 4 over 2 factorial times x minus 4 squared. So let's see here. We're going to have an x minus 4 squared in the numerator. This whole thing is going to be negative. We're going to have a 2 factorial down there. So 2 factorial, 32, x minus 4 squared, all negative. All right, good to go on to the next one. For the next one, we have f triple prime of 4 over 3 factorial. And then we have an x minus 4 cubed. So this is going to be 3 times x minus 4 cubed over 256 times 3 factorial. And that's all positive. And that's it. For this problem, we want the third order Taylor polynomial for x to the 4th generated at x equals 1. So we're going to have to take the function value and the first 3 derivatives at x equals 1. And we're going to get a bunch of terms that all have x minus 1s in them. So let's start with just plugging 1 into f of x. That's just going to be 1 to the 4th, which is just 1. Next, we need the first derivative evaluated at 1. So that's going to be using our power rule here. 4x cubed. Plugging 1 into that, that's 4 times 1 cubed, which is 4. Second derivative, we're going to have 12x squared. Evaluating that at 1 just gives us 12. And for the third derivative, we have 24x. Evaluated at 1 is just 24. So our function then, or at least our third order polynomial, that's going to be this initial f of 1. Plus, we're going to have f prime of 1 times x minus 1, so 4 parentheses x minus 1. And now everything is getting one of these x minus 1 terms in it. So for the next thing, we have f double prime of 1 over 2 factorial times x minus 1 squared. So we're going to have 12 x minus 1 parentheses squared all over 2 factorial. And then finally, for this last term, we're going to have 24 x minus 1 cubed all over 3 factorial. And there we are. For this one, we want the third order Taylor polynomial generated by sine of x at x equals pi over 4. So I need f of pi over 4, and I also need the first three derivatives of sine of x at pi over 4. That'll help me construct my polynomial. So sine of pi over 4 is just going to be root 2 over 2. That's just f of pi over 4. First derivative, well, we have the derivative of sine, which is cosine. Evaluating that at pi over 4 also gives us radical 2 over 2. Derivative of cosine to get our second derivative now, that's going to be negative sine of x. And evaluating that at pi over 4, that's going to be negative root 2 over 2. And the third derivative, that's the derivative of negative sine of x. That's going to be negative cosine of x. Evaluating that at pi over 4 also gives us negative root 2 over 2. So constructing our third order polynomial, our first term is always going to be f of the original plug-in value. So that's just root 2 over 2. Next, we're going to have f prime of pi over 4 times x minus pi over 4. So that's going to be radical 2 over 2 times x minus pi over 4. And now it gets a little bit messier to write out. So for the rest of these, I'm going to have an x minus pi over 4 term, and the exponent's going to keep going up. I'm just going to put that over on the side, kind of by itself, and I'll have everything else next to it just be one big coefficient. So for this next term, I'm going to have my second derivative, negative radical 2 over 2. But now, remember, that has to get divided by a 2 factorial. So I'm going to have all of that, so minus 2 radical 2 over 2 times 2 factorial, and then we're going to multiply that by an x minus pi over 4 squared. Finally, for the last term, we're going to have minus radical 2 over 2 times a 3 factorial downstairs, because the third derivative has to get divided by a 3 factorial. And then I'll have an x minus pi over 4 cubed. For this problem, I want the third order Taylor polynomial generated by f of x equals 1 over x at x equals 2. So I'm going to start by doing just f of 2, which is going to be 1 over 2. And now I'm also going to figure out the first three derivatives of 1 over x evaluated at x equals 2. Then I'll build my polynomial based off of that. So for my first derivative, well, my initial function is really x to the negative 1. So using my power rule, that's negative x to the negative 2, evaluated at 2. So this is really negative 1 over 2 squared, which is negative 1/4. Taking the next derivative now, using my power rule, this is going to be positive 2, x to the negative 3. And if we evaluate that at 2, well, this is really like having 2 over 2 cubed. That's going to be 2 over 8, which is positive 1/4. And then finally, the third derivative, that'll be negative 6x to the negative 4th, evaluated at 2. This is really negative 6 over 2 to the 4th. That's negative 6 over 16, which is negative 3/8 if we reduce it. Putting it all together now, the first term is just going to be f of 2. And after that, we're going to have f prime of 2 times x minus 2. So negative 1/4 parentheses x minus 2. And let's see here. I guess you could also write it as x minus 2 over 4. Same difference. Moving on to the next one, we're going to have x minus 2 squared over 4. And we're also going to have a 2 factorial in the denominator, because your second derivative always gets divided by that 2 factorial. And for this last one, we're going to have a negative 3x minus 2 quantity cubed in the numerator. Denominator, we've got this 8. We've also got a 3 factorial that always comes with this triple derivative. And there it is. For this one, we want the first 4 non-zero terms in general term of the Taylor series, generated by e to the x over 2 at x equals 1. So we need to figure out f of 1, and we also are going to need, let's see, enough terms to get 3 more non-zero terms out of it. So we're going to have to keep taking derivatives until we get at least altogether 4 things that are not 0. So let's start with just f of 1. That's e to the 1/2, which is just the square root of e. Now f prime of 1, that's going to be 1/2 e to the x over 2, using our chain rule there. Evaluating that at 1, that's going to be 1/2 e to the 1/2, or just 1/2 times radical e, or just simply radical e over 2. Next, for the second derivative, we're going to have all of this stuff times a tail of 1/2, so that's actually 1/4 e to the x over 2. Evaluating that at 1, we're going to have the square root of e over 4. And then finally, third derivative, we're going to have another 1/2 getting multiplied out in front here with the chain rule. So that's going to be 1/8 e to the x over 2. Evaluating that at 1, we get radical e over 8. So you can see there's definitely a pattern here. I'm writing out our polynomial now. We've got 4 coefficients that are not 0, so this is actually enough to do the first 4 non-zero terms. After we do that, we'll figure out the general term based off of the pattern. So my first term is just going to be f of 1, so radical e. After that, I'm going to have radical e over 2, with basically f prime of 1 times x minus 1. So I could write that as radical e parentheses x minus 1 all over 2. Next, I've got radical e parentheses x minus 1 squared over 4. But don't forget there's also a 2 factorial in your denominator that always comes along with that second derivative. And we've got this third derivative that, be careful again, because this always has a 3 factorial downstairs. So we're going to have plus radical e parentheses x minus 1 cubed over 8 times 3 factorial. And now for the general term, well, looking at the pattern here, we always have a radical e. We're going to have an x minus 1 to the n power, and we're going to have a 2 to the n times n factorial. So there's everything we need.